Hello class and welcome to today's lesson on 1.4. Going to be a little bit of a review from some of our days before here. So students will know how to count options of various word problems. Our central question is, when do you use NPR, NCR, and the multiplication counting principle? So for today, what you're going to want to do for our note part of this is make this chart right here. So you want to give yourself enough space for each one. One column here for multiplication counting principle, one for permutation, and one for combinations. Again, feel free to pause videos whenever you need to, if you need to catch up, things like that. So to start, some keywords for each one. When we're talking about multiplication counting principle, if you see things like one of each, maybe sandwiches, like if you're talking about types of meat, types of bread, all of our license plate problems, those are all MCP problems, and maybe one type of blank. When you're talking about permutations, some words to look for: arrangements, arrange, order, race, placement, right? First, second, or third, right? Those are some key things to look for that might tell you it's a permutation problem. For combinations, select, choice, choose, a group, or committee. Those are often words you see in combination problems. I'm going to move forward, but again, feel free to pause this video if you need to catch up on some of those words. When do you use each? For the multiplication counting principle, when you're selecting one of each from multiple events that are happening. Permutation you use when the order matters, when you're taking a small group from the whole larger group. And then combinations is when the order does not matter, when you're taking a small group from a whole larger group. And then one example of each here. So for MCP, I have 10 toppings, 5 ice creams, 3 cones. How many options do I have? Right, we'd take 10 times 5 times 3. For a permutation problem, we have 10 people in a race. How many ways can you assign first, second, and third? Right, we'd do 10 and then NPR 3, right, because the order matters because of that first, second, and third there. For a combination problem, you have 10 people in a class and you're making a group of 3 people, right? The group of 3 doesn't matter who gets picked first, they're just part of that group. And so this is 10 NCR 3. So again, feel free to catch up on those, and we're going to get to some examples here. So what we're going to do on the next ones, we are going to mark the text. We're going to go through, skim through each problem, circle any keywords or phrases. I'm actually going to highlight them. And then for each example, decide if the order matters. You can either put an O by the problem or an O with a cross through it, or I'm just going to talk through them here. So what I'm going to need to do is open this up. So we go here. First problem, grab the highlight tool. So we want to look at some key information from each one. So notice this first problem, Mark has 5 pants, 7 shirts in his closet. He wants to wear a different combo for as long as he can. How many weeks can he do this for? So if we're looking at this information, right, what I highlighted are some key pieces. So 5 pants, 7 shirts, wants to wear a different combo. So right, the first thing we're going to have to do is figure out, well, how many total outfits are there? So right, this is where we're going to use MCP. We're going to do 5 times 7 gives us our 35 outfits. And now I want to figure out how many weeks, right? Key thing I highlighted here, right? 7 days in a week. So we're going to take our 35 outfits, divide by 7, and he could do this for about 5 weeks. It's 5 weeks there. Again, if you want to pause on a certain problem, feel free to do so. I'm going to move to the next one. So you are doing a class project and need to form a group of 5 people. There are 40 people in class. How many ways can a group be created? So, right, we're looking at this information, right? First thing we should notice, as I've highlighted it, and I'll highlight it over again, right? The word group. That should tell us right away the order is not going to matter in this case. And so we're going to do an NCR problem. So, right, we're going to do 40 NCR5, and we find our answer to be 658,008 ways. Next one, we have 20 students enter a contest at school. So, right, we'll go back to yellow here. So 20 students enter a contest at school. Contest offers first, second, and third place prizes. How many ways can the winners be selected? Right, if we notice this, first, second, and third, right, the order is going to matter here. So this is going to be a permutation problem. So we're going to do 20 NPR3, and we get ourselves an answer of 6,840 different ways. Next one here, Baker has 4 different types of frosting, 3 different types of sprinkles, and 8 different cookie cutters. How many different combinations can the baker create if each cookie has 1 type of frosting, 1 type of sprinkle, and should say 1 cookie cutter? So if we're looking at this one, right, this isn't a permutation or combination one. This is, we have 3 steps to follow, and we got to multiply those steps together. So we're going to take 4 times 3 times 8 and find that we have 96 different types of cookies that we could make. Next one here, license plate problems. So, right, reviewing from a couple days back. So a series license plate is to be produced, right? We know license plate problems are dealing with MCP. They'll have the same pattern of 3 letters followed by 3 numbers. So, right, if we remember what we do here, right, for every part there's a letter, we got to use we have the choice of every letter from the alphabet. So, right, 26 options. And then for the numbers, we have any number from 0 to 9. So that's 10 total numbers. So what we do here, right, we take our 26 times 26 times 26 for those 3 letters. Then we multiply it by 10 times 10 times 10 for our 3 numbers. And that should get us a total answer of 17,576,000 different license plates. Next one here, at an ice cream store, there are 5 flavors of ice cream. Strawberry, vanilla, chocolate, banana, and mint. How many different 3-flavor ice cream cones can be made? So notice there are 5 total flavors. We only want 3 of them. With this one, it's kind of up in the air whether the order is going to matter or not. So I actually did both options. So right, if we look here, right, 5 flavors, 3-flavor ice cream cone. Kind of up to you whether you want to think that the order matters or not. But if we're looking here, right, we would do 5 NCR3, and there'd be 10 options of 3-flavored cones. If we thought, order doesn't matter, 3 flavors in 1 ice cream, they're all going to taste the same. And then if maybe you're in the boat where, it's going to matter if chocolate's first or vanilla's second, things like that, we might do a 5 NPR3 and get 60 different types of cones where the order is going to matter that we put them in. Next one here, you're forming a committee for the school board. Committee is a key piece here. You need to select 3 people from a group of 45. How many ways can you select your committee? Well, right, when we see that word committee, similar to the word group, right, that's telling us they're just part of that thing. The order does not matter that they get picked in. So this is going to be an NCR problem. So we go here, right, 45 is our large group, NCR3, and we should get 14,190 ways. Excuse me there. Number 15. A deli you can choose from either Italian bread, whole wheat, or sourdough. We use different colors here. You can choose turkey or ham as your meat, and then cheddar or Swiss as your cheese. You have to choose a bread, meat, and cheese. How many possible sandwich combinations can you have? Notice we have three choices, or three steps, sorry. Choose the bread, choose the meat, choose the cheese. So this should tell you right away, different steps means we're using the multiplication counting principle. Right, our first step, we have three options: Italian bread, whole wheat, sourdough. For meat, we have two options. And for cheese, we have two options. So we take our 3 times 2 times 2, and we see that we have 12 different options for our sandwiches. So last example here, there are 5 pictures, but only 4 display cases. How many different arrangements of pictures in display cases can be created? So the key thing to look here is this word arrangements. That's telling you we're arranging them or putting them in some order. So this is going to be an NPR problem. So at our large group, our big number is 5. We're choosing 4 of them, and the order matters. So we're going to do NPR, so we get 120 arrangements. So fun little thing, come up with your own, right? Similar word problem to maybe something like this, whether it's an NPR one or NPR, NCR, or maybe an MCP problem. Just have some fun with it, come up with one on your own. But that is it for today's lesson on 1.4.